Okay, so very brief summary for the shortest path problem. There are many decision variables that can be boiled down to determine the shortest path, or like the least costly route to go through a network. For example, emergency vehicle routing can be one that will use this kind of algorithm to determine how to find the quickest path to go from A to B. Okay, and this is a special case of the transshipment problem because we assume that in this case there is only one supply node, okay, with a supply of -1, and there is one demand node with a demand of 1, 2, and all other nodes have a supply or demand being 0. And we illustrated this as think about this in a way that you just transport this one car from this starting point to the destination point. That's why you have a supply of 1 and a demand being 1. And all the other nodes, all the transshipment nodes, which means the intermediate points, they should have a demand of 0 because you don't want your car to just get stopped there before it goes to the and it never goes to the destination. Okay, so that's the summary of this problem. One thing I would like to emphasize here that first, for the constraints, we know that we write the constraints conform to the balance of flow rule, and we'll have to determine the relationship between your total inflows and the total supplies and total demand first. And based on the sign between these two values, we determine the sign in your constraints. And so the constraint will be inflow minus outflows greater than equal to, or less than equal to the supply or demand, the sign being determined by the sign above. And in your homeworks and in the test, please just don't write inflow minus outflow to replace all the actual constraints. Okay, you have to write out all the constraints, write out what are the inflows and what are the outflows for each node. You should have one constraint for each node. Okay, and the other thing I found previous students get confused is that they used those say like the driving time or the scenic points given in the constraints. So they use them as a coefficient in the constraint, which is not right, because in the constraint you only put those inflows and outflows, and they have nothing to do with those coefficients. You only use those coefficients in the objective function part. Okay, so that's this problem. And again, we're going to implement this problem next week in class.